Hi everyone. So today we're going to finish off our work on conic sections by looking at the Cartesian form of those equations. Okay, so in the last lecture we went through the polar form of the three conic sections and we looked at how to sketch them given the polar form of the equation. Okay, so if you did the homework last time, you would see the Cartesian form of the parabola, ellipse, and hyperbola. Now we're going to look at finding the intercepts, finding the focal points, and then at the end sketching them. Okay, so let's look at the first one, which is the ellipse. Okay, so the ellipse is given by x over a, all of that squared, plus y over b, all of that squared is equal to 1. Okay, where a and b are just some constants. Okay, so if we want to try and sketch this, we know that given any kind of equation, any function, we need to look at the x-intercepts, the y-intercepts, and that gives us an idea of the shape of this thing. Okay, so let's look at the y-intercepts. Okay, so for the y-intercepts, we need to let x be 0. Okay, and if x is 0, then we get y squared is equal to b squared, and so y is equal to plus or minus b. Okay, so we get two y-intercepts, so 0b, 0 minus b. Okay, what about the x-intercepts? Okay, so for the x-intercepts, we need to let y equal 0. So then this will give us x squared is equal to a squared. So x is equal to plus or minus a. Okay, so this gives us our two x-intercepts, a and 0, minus a and 0. Okay, and that's all we need to sketch the ellipse, because we know that it's sort of circular shape, but it's a bit stretched out. Okay, so if we look at the axes, we're going to have the two endpoints of the ellipse at minus a and a. So minus a and a, so along x. And then along y, it's going to be b and minus b. So maybe somewhere over here, that's b and minus b. And then we can connect them, we can connect it like this, and that gives us our rough ellipse shape. Okay. Now we can also use the values of a and b to find the focal points. So remember, the focal points are somewhere here, and we called them F1 and F2. Okay, so how do we find the focal points? Well, they are located at plus or minus c. So the focal points are located at plus or minus c and 0, where c squared is equal to a squared minus b squared. Okay, so we know a and b from the given equation. We can find c, and then that will tell us where these focal points are. And that's all you need to sketch the ellipse. Okay, so let's have a look at an example. Okay, so we're given x squared over 16 plus y squared over 9 is equal to 1. Okay, so this is not quite the form of the ellipse that we're looking for. Because remember, we need something like x over a, all of it squared, plus y over b, all of it squared. Okay, we don't really have that here, but we can adjust this to get what we want. So rewriting this as x over 4 squared plus y over 3 squared is equal to 1. This gives us our values of a and b that we can use. Okay, and what about the focal points? That's going to be c squared is equal to a squared minus b squared. So that's going to be 16 minus 9, which is 7. So we know that C is going to be plus or minus root 7. Okay, so we've got the values of A, we've got the values of B, and the values of C. We can use that to then sketch this ellipse. Okay, so it's going to be something like this. Okay, along the x-axis, that's our value A and minus A. So it's going to be 4 and minus 4. So that's, let's say, somewhere here. That's 4. Somewhere here, minus 4. And then B has a value of 3. So the intercepts are at minus 3 and 3. So that's somewhere here and somewhere here. Okay, and then we can just connect the dots to get our ellipse shape. So something like this. Okay, just a rough kind of ellipse shape, that's fine. And then the focal points, they're going to be somewhere inside here and equidistant away here. Okay, and that's our minus root 7, 0 and root 7, 0. So those are the two focal points. So we can label those F1 and F2. Okay, and that's all we really need to do to sketch the ellipse. Okay, now just a little bit of terminology. The width of the ellipse, so from minus A to plus A, we call that the major axis. So there, this is the major axis, okay, from minus A to A. And then from minus B to B, we call that the minor axis. So that's just a little bit of terminology that we use when describing the ellipse. Okay, so we've got the major axis and the minor axis. Okay, so the next thing is looking at the hyperbola. So it's similar to the ellipse. You find your intercepts, your focal points, and then you can sketch it. However, for the hyperbola, we need to be careful to also include the asymptotes. Okay, so parabolas and ellipses, they don't have asymptotes. Hyperbolas do have asymptotes. Okay, so that's number 2, hyperbola. Okay, and like I said last time, there's 2 kinds of hyperbolas depending on the orientation of the branching. So you can have branches going up and down, or you can have the 2 branches going left or right. Okay, and that's the sign that you pick. So you can have the plus sign or the minus sign, and that gives you the 2 orientations. Okay, so we have a similar thing with regards to the Cartesian form. Again, you can have the plus or the minus sign. So we can have it as x over a squared minus y over b squared is equal to 1. Okay, so the x squared term minus the y squared term, that's the 1 orientation. Or you can have the other orientation, y over b squared minus x over a squared is equal to 1. So you see they differ by a minus sign. So in the first equation, the minus is with the y squared term. In the second equation, the minus is with the x squared term. And that affects the orientation, okay, whether the branches are going up and down or going left and right. Okay, so let's have a look at the first one, and then we'll see what that gives us. And then the other one will just be the other option. Okay, so we only need to look at this first one. Okay, so let's look at the x-intercepts and the y-intercepts. So for the x-intercepts, we know what to do. We need to let y be equal to 0. Okay, so if y is equal to 0, then we have x squared is equal to a squared. So x is equal to plus or minus a. Okay, so we have one intercept at a0 and another intercept at minus a0. Okay, good. What about the y-intercepts? Okay, so for the y-intercepts, we need to let x be equal to 0. Okay, similar to what we did before. If x is equal to 0, then we have y squared is equal to minus b squared. But there's a problem here because y squared is positive because we're squaring it. B squared is positive because we're squaring it, but we got this minus here. So we have a positive is equal to a negative. We can't have that there's a problem there. Okay, so what this tells us is that there are no y-intercepts. So this particular form, so the first one with the x squared term minus the y squared term, there's no y-intercepts. If you looked at the other case where it's y squared minus x squared, then in that case, you won't have any x-intercepts. Okay, so that tells you what kind of shape we're dealing with. So for this one, we can roughly sketch this. Since there's no y-intercepts and only x-intercepts, it must look like this. Okay, so here we've got our two x-intercepts, but no y-intercepts there. So that is this kind of picture here. Okay, and then for this other picture, let's just put it at the top here. For this picture, it's going to be something like that, where there are y-intercepts, but no x-intercepts. Okay, so those are the two different orientations that we can get. Okay, so that's looking at the intercepts. Now remember with hyperbole, we also have the asymptotes. Okay, so something like that and that. Okay, there's the two asymptotes for the graph. Okay, so how do we find these asymptotes? So I'll just show you how we find them. And then from this, we get the two equations for the asymptotes. But in the assessments and tests, you don't need to do all of this again. You can just go straight to those final equations. Okay, but this is how we get those two equations. Okay, so let's do it with this first option, the one underlined in green. And then it's very similar to show that we get a similar thing for the other option. Okay, so let's say we have this first case, x over a squared minus y over b squared is equal to 1. And you can do a similar thing with the other case. Okay, so just going to rearrange this a bit so that we get y squared over b squared is equal to x squared over a squared minus 1. Okay, now let's take the b squared term over to the other side. So we have y squared is equal to b squared over a squared times x squared minus b squared. Okay, good. Now let's take the square roots on both sides. So we're going to have y is equal to plus minus the square root of b squared over a squared times x squared minus b squared. Now I'm going to factor out b squared over a squared times x squared from the square root. So we get y is equal to plus or minus square root b squared over a squared times x squared into 1 minus a squared over x squared. Okay, so that's just factoring it out there. Now we can take the roots and we end up with y is equal to plus or minus b over a times x. And then we still have the roots of this other term, 1 minus a squared over x squared. Okay, now we know asymptotes show the behavior as x gets very, very large. So if we look at this expression and we imagine x being very, very large, then this fraction a squared over x squared is going to get very small because we've got a large number in the denominator. So in the limit, this term vanishes. So we're just left with the square root of 1, which is just 1. So we end up with our two asymptote equations. Y equals b over ax, you can put a plus. So that is for the increasing asymptote positive gradient asymptote, and we get y equals minus b over ax, and that is for the decreasing asymptote. Okay, so if we have something like this, let's put in the hyperbola, let's put in our asymptotes, like that, and like that. Remember, we put asymptotes with the dotted lines. If we have our hyperbola doing this and this, right, something like that, then this increasing one over here, that's going to be given by plus b over ax. That's the equation of that line. And then the decreasing one, that's going to be minus b over a times x. Okay, so those are the two asymptote equations. Okay, so this is for the first case that we did here. This one, you can do a very similar thing with this other case, and you'll get the same answer. Okay, so it doesn't matter which orientation you have with the hyperbola, you have the same asymptotes. Okay, so it's either in the top and bottom half between the asymptotes, or it's in the left and the right half, again, in between the asymptotes, but the asymptotes stay the same. Okay, so that's the asymptotes. What about the focal points? So the focal points are located at, and then we have two of them. So it's going to be, in this case, we have the focal points being along the y-axis. So it's going to be 0 plus or minus c, where c squared is equal to a squared plus b squared. So in this particular picture, the focal points might be over there and over there. Okay, something like that. If the hyperbola was orientated differently, then we would have the focal points being along the x-axis. Okay, so it depends on the orientation. So this is the first orientation, like with the picture above, or you can have the other orientation. Focal points are located at plus or minus c with 0. So again, along x. Same thing, c squared equals a squared plus b squared. Okay, so it depends on the orientation. Okay, so let's have a look at an example of sketching a hyperbola. Okay, so let's say we have y squared over 25 minus x squared over 9 is equal to 1. Okay, so we know it's a hyperbola because we got the minus in the middle. If that was a plus, then it would be an ellipse. Okay, now this isn't in the standard form that we like, because remember, we would rather have it as y over b, all of it squared, minus x over a, all of it squared. Okay, so we actually need to take the square roots of 25 and the square roots of 9 to find the values of b and a. So let's do that. So this first one, we're going to write as y over 5, all of that squared. And for the second term, that's going to be x over 3, all of that squared. So now we can see what the values of b for the y term and a for the x term are. Okay, so we know that it's a y squared minus x squared kind of hyperbola, which means there are only y-intercepts. Okay, there's no x-intercepts. So we don't need to worry about those. So y-intercepts. Okay, so again, y-intercepts, we let x be 0. And if x is 0, that means y squared is equal to 5 squared. So y is equal to plus or minus 5. Okay, so this gives us two y-intercepts, one of them at 0, 5, Another one at 0, minus 5. Okay, good. What about the focal points? Okay, so remember how we found the focal points. We have that equation c squared is equal to a squared plus b squared. We know the value of a and b now, so that's going to be c squared is equal to 34. We just add those two together. So c is equal to plus or minus root 34. Okay. And since we already know the orientation of this hyperbola, we know that these focal points must lie on the y-axis. So our two focal points are going to be 0, root 34, and the other one, 0, minus root 34. Okay, similar to the y-intercepts. Okay, they're along the y-axis. Okay, so we've got the y-intercepts, we've got the focal points. Now we just need the asymptotes. Okay, so how do we find the asymptotes? We just use that equation, those two equations we found before. Here we go. Plus b over a times x and minus b over a times x. So our two asymptotes are going to be y is equal to plus 5 over 3 times x. And the other one is going to be y is equal to minus 5 over 3 times x. Okay. So let's try and sketch this hyperbola now. So we've got our axes, x and y. Okay. And remember what I said last time, draw in your asymptotes first. That will help with the sketching afterwards. So our first asymptote is going to be, let's say, the positive one. So it's going to be something like this. Okay, something close to a gradient of 1. And then the other asymptote will be something like this. Okay, the minus of that. Okay, let's put in our y-intercepts. It's going to be 0, 5 and 0, minus 5. So let's say over here and over here. So that's 0, 5, 0, minus 5. Okay, and then the focal points, that is 0, root 34, 0, minus root 34. So that's somewhere just above 5. So here, 0, root 34, and somewhere just below minus 5. So somewhere here, 0, minus root 34. Okay, so that's all the points that we need. We can now fill in what the curve looks like. So it's going to run along the asymptote, something like that, through the y-intercept, and then back along the asymptote like that. Okay, so that's for the top branch. And then the bottom branch is going to be very similar. We run along the asymptote line, through the intercept, and then back along the asymptote line. Okay, and remember these asymptote lines, they continue down like that. And our graph never crosses the asymptote lines. Okay, so it's like that. Okay, so that's everything we need to sketch the hyperbola. All right, any questions so far? Okay, no questions. Okay, cool. Let's set some homework for today. Okay, so we want to sketch the following conic sections. Okay, so the first one is going to be x squared over 4 plus y squared over 8 is equal to 2. Number 2, x squared over 5 minus y squared over 5 is equal to 1. And number 3, y squared over 6 minus x squared over 9 is equal to 1. Okay, so 1 ellipse and 2 hyperbolas. Okay, so sketch the following, and then remember to include, intercepts, focal points, and asymptotes. Okay. Are there any questions about what we've gone through today? Okay, cool. So the summative tutorial quiz tomorrow is only going to be on the stuff that we did last week. Okay, so we're not going to be doing sketching from Cartesian form. Okay, so it will just be up to sketching from polar form. Okay, so if I give you the polar form of a parabola, hyperbola, or ellipse, okay, you should be able to sketch that. And also converting between polar form and Cartesian form. Okay, like we did last week. Okay, and then on Thursday, we are going to start the new section on complex numbers and complex functions. Okay, if you do have any questions later on, you can post them on the WhatsApp group. Myself or the tutors can answer you, or you can email me if you want. Okay, I'll see you all tomorrow at the tutorial. Okay, bye everyone.